hacked, their accounts hacked. They actually get their accounts hacked on the internet, and then they no longer have access to those accounts, and a lot of things can happen. So imagine a reverse scenario where instead of you getting different codes for you to access the games in the amusement park, the simple thing that you are just going to get is something like a wristband. So I'll just give you an example, like a wristband like this one that you have to put on your wrist, and then that will give you access to every other game that you want to go and access, right? So, okay, I see there's a Ruth who want to speak. Let me just finish, and then I can let you ask any questions. So when you wear that band, you can go around it any game and then try to access that game, and you will just be using that single band until probably you have to have some credits or some units for you to be able to continuously access any game that you want. So coming back to the example of the internet, imagine you don't have to have a lot of passwords on you or a lot of accounts for you to actually access each and every account on the internet. So imagine a scenario where you use the same identity and the same authentication for you to access Facebook, Twitter, and any other website that requires authentication for you to access. You don't have to be using different types of passwords and all the passwords that you're always asked to have on the internet. So this is basically what the internet identity is. It makes you or gives you number one, the security that you have a band that nobody can take away from your hand. Unlike with a password, somebody can just access it, probably from your cache or something like that. But when you have a band that is always on your hand, no one can take it away from you. So you can think of it, because the internet identity uses a unique ID that is from any of the devices that you're using to try and access whatever website that you're trying to access. So something that is unique to you is definitely your fingerprint. So that is one of the disadvantages, however, of using internet identity, is that you have to have a device that is kind of supported or supports the technology in a way. So a fingerprint is unique to you. There's no one who can, like, in a way, duplicate your fingerprint. So if you have a fingerprint on your phone, or you have a Face ID, like some of you use iPhones and Samsungs, that is something that is unique to you. So when you set it up, that is your internet identity, and that and only that can be used to access any website that you would want to access. So for you to set up, we'll go through the setup probably tomorrow when I have my internet back, and I can do it from my laptop and show you how you can do it. But I just wanted to go over and explain to you guys like the reason why the internet identity exists, and it's a technology that you will definitely see in the future. Even you'll see it's being rolled out to even Gmail and other Google services, and you'll see it will be in a different form, but the one from Dfinity or in the internet computer is more secure, because then it is decentralized and it's on the blockchain.
Thank you. Thank you, Mr. Confidence. Maybe there was a question from, was it Ruth? Maybe we can address it before we proceed to the next stage.
Yeah, I'm not sure if she's still in the. I saw. I think she's having. So there's Ruth. Yeah, Ruth Kaseke. You can unmute your mic. I saw you raised your hand. You can go ahead and ask your question.
My apologies. I didn't intend to raise my hand. So you can continue. I don't have a question.
We can't.
I'm sorry, Ruth. Can you speak up? I can't hear you.
Oh, I think she have a connection problem.
Okay, it seems she's having an internet connection problem. Maybe if you can still hear us, you can type in the chat
In the
box
chat, yeah, you can type
the
a question
question.
in the chat.
Yeah, and if anyone has a question, actually, you can go ahead and type it in the chat,
Okay, sure.
and we can respond. So, yeah, so Mr. Enoch, you can take it away.
Okay,
Um,
okay, sure. So there's a few things I would like to talk about, especially about the program, how we are going to be doing it, and how you need to go about it correctly. So I've been talking to some of you, and there seemed to be like sort of confusion. Maybe we didn't explain some things well, like about the nature of the project of the hackathon. So this program is about building on the internet computer, right? Building on the internet computer in canisters. So some may have some other projects, like some other projects. They have some coding projects they want to build and maybe submit in the hackathon or whatever they are thinking. Uh, if you want to submit your project, that project, ETF, you can start try to find a way of, okay, there's a question. You can try to find a way of implementing like that idea in a canister, like in a on the internet computer. That way, like your project will be accepted, like for the hackathon. And I also, yeah, so I just have to clear that away. Whatever you are going to build, it have to be on the internet computer only, like in canisters. And also just to explain something else about the internet computer. Um, you cannot only build in TypeScript. I was also receiving some other questions. Others were also confused. TypeScript is not the only language you can use on the internet computer. You can use Motoko. You can also use Rust to build your canisters. And but for this program, we are focusing on TypeScript. But if you are adventurous and you would like to explore, you can definitely do that. And we will be providing some resources as we go on, and you can look into those and all those systems and see how you can do, like maybe whether in Motoko or in Rust. So yeah, now that we get that out of the way, I think I would like to go through the course, like how you are supposed to do the decade course in general, and make sure you can participate in the hackathon. So let me go ahead and share my screen and show you guys. So I would like to go through the decade course and show you guys how you are supposed to go about it and give you a few tips that might help you along the way. So we are here on decade, and you can see, so this is the internet computer course. You come here and you get started. Um, so with TypeScript Smart Contract 101, this is the one we are going to take, and then we can say C challenge. Um, when you are in, read all the instructions. and go ahead on start now. Right, and once you're in, once you start the course, okay, you still have to start again here. I suggest you read all these, you watch all these videos, and so you can really get to understand what we are building, like what you're supposed to build, and how to understand, and to understand how the internet works in general, how canisters works, how does ICP work. Then let's proceed to next. And now this is the tutorial you have to go through first. So as I mentioned in some emails I sent out for the past few days, and also in the group, I guess, that this course is using kind of an old version of the ASO CDK. The ASO CDK is the one that allows you to build canisters on the internet computer with TypeScript. So this tutorial is using an old version, and it comes with a few problems with it. It even takes very long to deploy, and also it has been having some weird bugs recently. So first, what you need to do is to go through all these steps. Each step, the steps, and like what you're basically being taught here is still accurate information. So you don't have to jump that. You have to go through. You have to go through this course, the tutorial, and follow all the instructions and install everything you need to install. And as you progress with the tutorial, when you get to the bottom, like to the end of it, where you actually need to deploy this, where you actually need to deploy your canister here from the tutorial, this is where you need to use the newer version of this tutorial, which I created and I sent out, and the email of it, the link to it as well in the email. So you need to go to that canister, to that GitHub repository. This is the one. So you come here, you copy the link. So after you copied the link of the repository, you can create a directory for it, so you can deploy it locally. You might want to call it maybe tutorial, I guess. So this setup might be different from yours, because I am using Ubuntu, and if you're using Mac or Windows, I'm sure it will be a bit different, but it's basically the same thing. So now I can clone the repository, right? Then I can seed you into it. In my VS Code. The next important step I need to do first is to install the npm package, the packages, these ones here. So I install them by running the script npm, the command npm install. Yeah, now that the packages are installed, I can deploy the code. I can run pfx deploy, and let's give it a few seconds. And there we go. The code has been deployed. The canister has been deployed locally. So what this means is like it has been deployed on the local replica. So when you installed the IC CDK, what you basically did is like you installed like a simulation of the actual internet computer, but locally. So this canister is actually running on your local replica of the internet computer. So you can now start interacting with the canister. You can open this candid interface. So you can open this URL, this message for the URL text. Then you can start interacting with your canister. So you can see in the canister here we have these methods. We have these methods. Get messages, get message, add message, delete message, etc. And you can see they both take some different types of inputs. So here you can see on the add message, you just need to pass like the URL, um, title, body, then you call it, and the message is saved. Um, so you can see the message has been saved with a unique ID, this ID here. You can copy it and you can use it like to get the message itself. Also, you can create another message, second message, message. You call it, yeah. And now if you, let's say you call get messages, you now get all the two messages we just created. And if you copy the ID again, you can even delete the message. If you paste it here or delete, the message have been deleted. And if you call get messages again, we can now see only one message. So now just from something as simple as this, you can see that you can basically build like anything, any sort of CAD application you might want using the canister as your backend and your database. You can create anything, any social media application, what's not. So after that, yeah, you will need to continue to the next step of the decade tutorial, which is doing the actual challenge. So here, okay, so here they're just like guiding you on how you might go about it, like for the first time. And here you will be calling the functions from the terminal. You can definitely do this. I can like to interact with your canister from the command line. So I can even copy this command, and I come here to a terminal and I can paste it like this. Uh, yeah, the message is welcome, hello world. Let's come and check if it actually been saved. Let's refresh. Let's get messages. And we have it here. Welcome, hello world. So you can interact with the canister from the command line or from the candid interface. Okay, so as you go to the next stage of the tutorial, yeah, just follow on the instructions, play around with your canister. And so the only different step you need to do when you're going this tutorial is instead of deploying the code that is being run, uh, that you were creating in this canister, you just have to deploy the one I gave you, and everything else is basically the same thing. So yeah, they teach you everything, and then you can take on the challenge. um, so this is the instructions. Where is it? Yeah. Develop a unique canister. The canister should not be a replication of existing concepts or ideas. Ensure your canister code is of high quality. It should be well structured, efficient, follow best practices, and thorough, documented with no bugs. Just go through this. And so you create your unique canister, and when you finish, you can submit it here. So a tip I would like to maybe to give you, so you may be like running out of ideas, like stuck on thinking, what can I build? What unique canister can I build? So one place you can definitely go and try to be inspired with some ideas. You can come here to on the ticket. You can come here to on submissions. You can come here on submissions, and you can start to see all these project other student have submitted before, and you can actually open this, like it's all public and free. You can go ahead here, and you can see the GitHub code for that. You can actually see what the student did, the implementation, and you can actually learn something, and this might help you to come up with some ideas on of what to build. It will be much easier to think what to build. So I advise you to first create a repository first for this challenge, so that you can submit it. um, and also we will also need to see that repository ourselves after you submit it. So yeah, that's it. And another thing, when you finish your challenge, you can now start thinking of what you want to build, of what you want to build next in the hackathon, like your hackathon projects with your peers, in groups from 3 to 5. So we can also get some inspiration from here, but you can also come here on the Internet Computer website, internetcomputer.org, and you can come here to the dApps. You can scroll down and then you can select dApps here. And you can see all these cool projects that have been built on the internet computer. And you can see here we have Discover actually have 200,000 users plus right now. We have Open Chat. Open Chat, we have District. Go through this project and you can basically get the idea of what is possible on the internet computer. What can you do? What can you build? And this can help you refresh your mind and to help you think of what's actually possible, what you can build, and you can actually have some good ideas and build something cool. And another important thing as you build on the internet computer, you can, if you have a nice project idea and you're actually confident about it, you can actually get some developer grants here from Dfinity. Like they range from 5K to 5,000 to 100,000. So you definitely want that funding. These days is kind of difficult in some spaces. But here, if you just have a nice project idea, you can actually get some funding and do the awesome work you want to do and improve the world. So, yeah, that's it. And also, this website is very important. You can learn almost anything about the internet computer. You can come to developer documents. You can use this AI tool. You can ask it anything. What are cycles? To generate some responses for you. And cycles on the internet computer are computational resources of bandwidth, MCU instructions, etc. So yeah, you can definitely learn anything from here, and it will actually improve your journey on the internet computer and build awesome projects. So this website is really, really helpful. Really helpful. You go through tutorials, guides, more talk or anything. So it's a really go-to resource when you want to know extra stuff about the internet computer.
Okay, there was a question from Say Titus,
Okay.
and he asked. He says, so is two questions. I'll answer the first one, then you can go ahead
Okay.
answer the second one in that. So the thought of a decentralized token pass or bend sounds great, but what happens if it gets stolen? Now someone just has access to all the rights I was supposed to. Okay, so that's a good question actually. So again, it's not only the band that you're going to use to get access. So it's going to be a combination of probably two or three things. So he said that he said that so you're going to have the band itself and probably it's something that is secret, like let's say, or you want to access the rights, maybe a handshake, or maybe a certain dance that you have to do before it's actually approved that you are actually the owner. So those two will have to go hand in hand for then uh, access to be granted. So if there is one and the other one is not, the access will not be granted. So it's not possible. And also just think of it like, how is it going to be possible for somebody to steal the band on you? So when I give the analogy of a band, just think of your device, right? If you have your device, okay, and then somebody steals it, even if they have your password, right? They can't have your fingerprint. It's not possible unless maybe if they cut it off your hand or something like that. They can have your password to your device, but they can't access the website or they can't use the identity because they don't have your facial recognition or your fingerprint. So it's not possible for somebody to steal it. I hope I have made it clear.
Yeah. Okay, yeah. Seem to be happy about the answer. And also the second question, is it possible to install a specific version of the CDK that's used in the tutorial? For example, with other languages with version management. Yeah, you can definitely do that. You can use any specific version you want, but of course that will come with its trade-off. I advise to do that like when you really know what you want to do with that version. Like maybe you're building a project and what you want at the particular time is only available in that version. You can definitely do that, but it's really not the most advisable thing. It's just best to use the latest version. But you definitely can, like for this ISO version, the one that is being used in the tutorial is 0.16.0. Yeah, and you can use it. You can do some workarounds, even those errors. You can go around them and still use it, but you still can use it. Okay, what about laptop which does not have a fingerprint sensors, poor camera, or facial recognition? You can use a mobile phone. You can you can use a mobile phone. This is uh, we had some challenges with the mobile phone as well. I don't know. Maybe I might need to have a session with you sometime and see what could be the problem. But you definitely can. Like myself, I use a phone like in all my authentication with the internet identity, and it goes pretty smoothly.
Yeah, like it's possible for you to link your phone to your mobile phone to your laptop or desktop. That is if you don't have any way of uniquely identifying yourself using your personal laptop or your personal computer. So you can replace that with a mobile phone. I think that's the easiest. There are other methods also, like there are certain keys. I forgot the name, but it's like a USB that you actually set up on your laptop, and then that one has a disadvantage that you always have to be walking around with it, right? And you have to also make sure that you have it on you all the time. But mobile phone is the easiest because everyone has a password or whatever the swipe pattern on their phone. And therefore, every time you want to log in into a website or you want to access any website on the internet computer, or that uses the technology of the internet computer, then you just go ahead and use either your face or your fingerprint. Usually, most of the devices right now they have that functionality. Another question from Sam. So,
Okay.
for front end development, is there any need for this type of authentication since for development we use laptop?
Okay.
Um, I'm assuming. Okay, there's somebody who's hot micing. Let me try to mute them. Okay. So, um, I'm assuming that you are mentioning using. So you said so for front development, is there any need for this type of authentication? Yes, of course. So if you are building, or you are the one who's building whatever the software, and you are now building the front end, that is mostly what you are going to use as the authentication. So if you are building computer, and your software or your application is based on the internet computer, that is methods that you can use, which is going to be really easy for somebody to have access. Because as you also advance, I think can also expand on that.
Okay.
There's something that is called a principle that you are going to use, and then it's really really important if you are going to be dealing with principles for you to include internet identity in that project. Okay.
Yeah.
Then another question is, how do we redeem our ICP rewards, and how do they actually work? Okay. Um, so after you have done your project, and if you have done your course, I mean, and you've submitted and you have passed, uh, your rewards will come after about 6 weeks. And in terms of how you want to use them, it's up to you. If you want to exchange, probably we will do a tutorial when we are done with the course, uh, and then we'll just show you how to exchange your ICP tokens into real cash or into real money, that you can actually use to go and buy your girlfriend or your boyfriend something. But basically, you can also keep them. They appreciate in value. It's up to you. Like I said, you are welcome to keep them for a longer time, or you can
Oh,
exchange them
looks like content is cut off. Okay. Yeah. So just to continue about the ICP rewards, I think because we wait for confidence to join in. So you can definitely once you receive them, it's actually very easy to redeem them. You can send them to a decentralized exchange, maybe Binance or anything, and you can easily convert them to fiat currency, to whatever the currency you want. And so yeah, I think towards the end of the program we will do a session, I think, on this, on how you guys can get your rewards. So for now I don't think it's something you should really worry about, but yeah, you can. Um, so yeah, don't worry, Stanford. We will get into these rewards in detail in the next few days to come. We are kindly requesting for the video. Okay, yeah, we are recording, and we'll share it with you guys after this session. We just like get it together and share with you. Um, yeah,
which video was being
yeah,
asked
yeah.
for?
Okay, yeah.
Is
Maybe
it this video that we are recording?
suppose which video? Yeah, yeah. You
Okay.
said this session. Yeah. So
Okay. Yeah. I'm sure tomorrow morning we'll share it with you guys.
yeah, yeah.
Any any further questions? I'm sorry. I think my internet had lost me there. Any other question? You guys, you're free to unmute your mic and speak.
Yeah, you can actually speak as well.
Okay. So one other thing I think I also wanted to speak on. I actually noticed there are a couple of part ones. I'm not sure how many are in this call. So we'll probably, or maybe we can arrange a session, because I believe part ones might be still on training wheels with this whole programming thing. So maybe to make it a bit more fair to you guys, we can arrange a separate session during the day, and we can go through probably some of the things that may be troubling you. I saw like there are others who actually had trouble with Node.js itself, and then I actually noticed it's mostly part ones. So you can suggest to us what time is good for you guys. We can do a separate session with part ones. I don't know if part twos would want to join, but this is, I think, part ones for it to be fair. So you're welcome to just inbox or suggest in the group what time would be good. Maybe we can do a session together tomorrow, and then we can go over it a bit more slower than how it is going with the rest of the group. I don't know if that sounds fair. But I see there's no further questions. Who wouldn't want to? Okay. There's a question. Okay, what are cycles?
Okay.
Okay. Do you want to take that one, Mr. Enoch? Should I go ahead?
Okay. Yes. Yeah, I can take this one. Okay. So if you are like in the blockchain, in the Web3 space, like on other blockchains like Ethereum, uh, Bitcoin, etc., there is a you pay for gas like when you want to perform transactions on the chain, right? You pay a fee for gas for the compute you are doing on the chain, and for the storage you are putting special like on Ethereum smart contracts and or on Solana you pay some fees like for any transactions. You pay gas fee, right? So on the internet computer now, cycles are the gas on the internet computer. But on the internet computer, they work differently. On the internet computer, it's called there is what is called a reverse gas model. So on other blockchains like Solana, Ethereum, the user who is performing a transaction, let's say it's a smart contract or anything, they pay for the gas themselves. But on the internet computer now, a user doesn't pay for any gas, but the developer who develop the canister, when they deploy the canister, they pay for the gas fee, which is cycles, that will pay for the compute and storage on the internet computer. But it's very cheap, like very cheap. Like if I'm comparing to Ethereum, on Ethereum, if you want to store like a gig of data, it costs literally millions on Ethereum. But on the internet computer, it's something like maybe $5 or so, very cheap. So yeah, cycles are what are you gonna say are the gas for computation on the internet computer. But the developer is the one who fills in the canister when they deploy their project. I
Yeah,
don't.
and to actually add on that,
Yeah, yeah.
so when your canister or whatever software you have written has certain methods or certain functions that it has, there's actually certain uh, functions that will require those cycles. So it's just like money that is paid every time that a function is called on. So let's say there's a function that requires, or probably that has a function of writing a new probably user to the blockchain, or maybe writing a transaction to the blockchain. So every time that method is called, it will require some fee to be paid for it to be executed. The reason why this is in existence is for the system to resist DDoS attacks. Because then, if somebody is to keep on calling on that function, they will need the more they call on it, the more they will need to pay. So it's always like an issue of, okay, if you have money to waste, go ahead and do it. The more you're going to try to do it, the more money you will lose, and that is on you. So that's the reason why there's those cycles, and they basically just work in a way that you need to pay for you to actually call for a function. And then there are also types of other functions that do not pay cycles when they are called. An example of a query function. So that is the use of cycles. But cycles are just like a smaller unit of ICPs. You can convert your ICPs into cycles and then use them in your canister, but you can turn your cycles back to ICP tokens. So basically, I hope you understand.
Yeah. Query calls are free. Update calls are the ones that use cycles. So both they basically, yeah, you can shoot the last question. Are the ones that basically go through what is called consensus on the blockchain. That's why they call cycles. Yeah, you can ask the question you want.
I think it's typing.
Yeah. Okay, what's the difference between canister and WASM code? Okay, so WASM code, or we can say like, is basically your canister that has been compiled and it's now running on the internet computer, right? You write your canister in TypeScript, you write it in Motoko, you write it in Rust. When you deploy it, it gets compiled to WASM code, and this WASM code is the one that runs on the internet computer. You get, so yeah, that's basically what happens. All the languages you might use to build a canister all get compiled to WASM, and
Yeah, so WASM is just basically stands for WebAssembly.
yeah, yeah, WebAssembly. You get it. WASM, WebAssembly.
And like what Enoch was saying, let's say somebody or you are building a certain software, right? And you are building with Rust, or and then there's somebody else who's building with Motoko, and then there's somebody else who's building with TypeScript. For these things to communicate together, there need to be some commonality, some region where it's common. Like, so this is the use of WASM or the WebAssembly. And that means if your canister was built with whatever language, it can communicate with other canisters, regardless of what language was used to build it. So basically, that's the reason why we have the WebAssembly. And actually, the WebAssembly, it gets installed inside a canister when you deploy.
Yeah. So just to add on that, remember, Sam, you asked like, what is Candid? Yeah. So we said you can create your canister in TypeScript. You can create it in Rust. You can create it in Motoko. But for now, for these canisters to communicate to each other, this is where Candid come in. It basically is like language agnostic. It can work with a canister that has been deployed, like that has been written in whatever language you wrote it in. And then when you deploy it into WASM code through the Candid interface, you can now communicate your canisters very easily. So yeah, just to add that to your question you had. So
Yeah, I think we have got to the hour,
yeah,
and I hope you guys have all your questions answered. If you still have questions, don't hesitate to come to our in DMs. You can also reach out through the group and just ask away a question. Don't be shy. There's no question which is a bad question or which is a terrible question. question. We are all learning. We're in the process of learning. We also build on the internet computer, but we are still in the process of learning. We learn new things each and every day. So this is also your chance to actually learn and ask, no matter how small the question is. Don't hesitate to ask. So yeah. Mr.
Okay,
Enoch,
yeah,
do you have anything else to say?
yeah. Just one last thing before we go. Just want to remind you guys that to participate in the hackathon on 30, like you and your teammates, at least 3 to 5, you should all have you should all have created your canister challenges on the CAD and submit them there. And we will also, I think we also send out a form where you can fill and send your GitHub links to your unique canisters. And then yeah, after that you will be eligible for the hackathon. Yeah, I think that's all.
Okay, that's awesome, guys. Yeah, I hope this was a very great session for all of you. We'll share this video tomorrow morning for you guys to go through. For those who might have missed some parts of this meeting. Thank you and good night.